Hello everyone, now we are going to start our new data structure, and this data structure is really important data structure in terms of interviews, in terms of competitive coding, in terms of anything. Whenever you encounter the complex topics related to computer science, this topic might be related to that question, right? So it is really important to understand this topic, and believe me when I say that this topic is going to be one of the most interesting concepts, one of the most interesting theories in the world of computer science. Okay, so this chapter, this data structure which we are gonna study is very important data structure because we can create variety of questions from it. We can create variety of questions and algorithms from it. There are various algorithms which we are gonna study in the later part of the session. In part 2, part 3, we will study different algorithms, right? So from the concept of graphs, we can derive variety of questions and variety of algorithms which are really important and which are the foundation for other concepts. Whenever you go to some complex theoretical computer science concepts like NP completeness or night tour problems or three body system problem, these are some of the complex problems in computer science. When you encounter this kind of problems, graph is the only data structure which you might be using around 80 to 90% of the time. So it is really important to understand this data structure, and at the same time, personally for me, this data structure is one of the life-changing sessions in my life towards computer science. Because of this session, I have changed my whole perspective towards computer science. So I will try my best to deliver one of the best lectures on graph which can be possible in the internet, and I am thinking of breaking this session into 4 or 5 parts because I want to cover each and every nuance of graphs. Okay, so first point, it is we can create variety of questions from it, and we can derive plenty variety of algorithms from it which lay the foundation for other concepts. Later whenever we go into development, if we are dealing with theoretical concepts, then this algorithms which we are creating in this graph, which we are extracting from the data structure graph, is gonna work out there, right? And at the same time, this data structure has some real-time application. Most of you guys complain me that DSA is more theoretical, we don't have any practical applications, we are studying all this but we are not implementing this concept in overall structure, we are not using this concept. But graph, there are n number of applications of graph. You know, one of the best example I can think of right now is maps, Google Maps. So Google Maps will show you the shortest distance between 2 points. So internally it is basically using the concepts of graph. So it has plenty of like real-time applications. Okay, so this data structure is more theoretical, and after studying the theory, after studying the overall concepts, we can directly apply to some of the most complex real-time problems in the world. Okay, I hope you have understood how important this data structure is. Now let us talk about what is a graph. What is a graph? So a graph is a collection, or you can say network of nodes which are connected to one another, This sort of hierarchy, you can say that this is a sort of hierarchical data structure. So this sort of data structure, that is network of nodes which are connected to one another, and this connection can be of any form. It doesn't follow any rule, but this is the formal definition of graph. Now you can see that this is the diagrammatic representation of a graph, and in graph we represent a single node. We call a node as vertex, and the line which is connecting two corresponding nodes, that is two corresponding vertices, the line which is connecting them, we call that line as a edge. Okay, it is really important to understand some basic terminologies to move further. Okay, so a line, basically a branch which is connecting two corresponding vertices is an edge, and a node in graph we call this as a vertex. Now if you recall the concepts of linked list, we follow a definite approach, that is a linked list follows a linear structure. All the elements in linked list are stored in a linear fashion like this. So it follows a condition, it follows that all the elements should be added in a linear format, not in hierarchical format. This is a condition of a linked list. Now if you recall the concepts of binary trees tells that for a particular node it can have maximum 2 branches, that's all, and the nodes will come under the parent node. It means that it forms a level in itself, right? So in linked list, in binary trees, whatever the binary trees might be, AVL, BST, red black trees, whatever the binary trees might be, in binary trees, in tries, we form some conditions that it should store some characters. In tries, the root node is always empty, right? So in all the data structures which we have studied till now, we have created some conditions. But when it comes to graph, there are no conditions. You can see that here random stuff is happening. A network, a node is connecting to another node and it creating a network in a random way. So this doesn't have to be necessarily in a ordered fashion, right? The network can be of any form. We can create a node like this, one will connect to this and this and this like this, and it will have corresponding connections like this. So the networking, the connection can be of any types and it doesn't follow any rules. Okay, now if I summarize, what is a graph? A graph is a network of nodes that are interlinked with one another. This is one of the definition, and I will say that parent of tree, if I say what is the parent of tree, if I move one level above than trees, then we will get graph. So trees are basically graph which follows a certain condition, that's all. So if we create certain conditions in trees such that it will have 2 nodes and all this kind of things, then it will become a tree. So parent of tree, if you consider what is the parent of tree, then the parent of tree will be a graph. So if you move one step further in data structure, then the parents of tree is nothing but graphs. Right, I hope you have understood. Now if I want to tell you a real-time example, the best example can be, I have already told you that Google Maps is one of the example, and let us consider that cities. So let us say that I'm having Delhi is a vertex, that is my node, and I'm having another city, Mumbai, and I'm having Vizag and Hyderabad, right? So the practical application of graph is that you can consider a single city as a node. Now each node is connected to other cities, other nodes. Okay, now what I can do here is that to travel from Delhi to Mumbai, it will have some cost, it will take some cost. Let's say it is taking 10, 30 and 20, right? So to travel the minimum path, to take a path in which we will have minimum cost. This is one of the practical questions, right? To solve this sort of problems, we will use the concepts of graph. In the example, I am considering a single city as a node and it is interlinked with other nodes, that is other cities. So this is the introduction of graph. Now here what we will do is that in this part 1 session, we will talk about more about theory. We will focus not on the code, but we will totally, I don't say that 100%, but around 80% I will focus on theory. I will make sure that you are very clear with the theoretical concepts. You know, there are some terms like directed graph, undirected, weighted graph, unweighted graph. You should be very clear with it. And we represent a graph using different methodologies. So you should be very clear with those. Okay, so in this whole session, around 80% of the session, I will talk about theory and I will make our foundation very strong such that we can tackle like coding problems, complex coding problems in the next upcoming sessions. Okay, now let us talk about edges. So we have divided our graph based on the edges. You can see that here in the given graph, this is the edge, right? So here I'm not having any value associated with that edge. So to connect 2 nodes, it will take some value. If there is no value, then it is said to be an undirected graph. We will study in a while. So here we divide a particular graph using 2 concepts, that is using the concept of direction, using the concept of weight. I will talk about in clear what are these. So let us talk about direction. So if I talk about direction, we have divided our graphs in two types from the perspective of direction. That is, first one, unidirectional. That is, I will have a node that is my first vertex and the second vertex, and I can only travel in a particular way. Here you can see that I can only travel in this way, and you can consider this as a one-way road, right? One-way road. So in one-way road we can't go back, right? We can't take U-turn. We have to go in a straight path, and if we want to come back, then I will rotate. I will travel all the way and I can come back, right? So you can consider this unidirectional graph. We call this as unidirected graph. So unidirectional graph is a graph in which we can only travel in a particular given direction. Here I can travel from A to B, but I can't travel from B to A because there is no direction like this. So if in a graph, if the direction is given, then it is telling that the overall travel set is restricted in some sense. Okay, so this is the first type of graph based on direction, and the second type is undirected, or you can say bidirected. So in bidirected or undirected, both are basically same. Here you can travel in any way you want. You can travel from A to B, B to A, whatever you want, you can travel here, right? So these are the two different types of graphs based on direction. Now I have told you that each edge, you can see that this is an edge, right? So edge can have some value. It is not mandatory to have some value. Okay, so here you can see that in the first example which I have taken, I am not having any value associated with it. So what is the meaning of weight is that the value associated with the edge, is known as the weight of the graph. Here you can see that I am having some value. To travel from Delhi to Mumbai, I will take some value, I will take some cost, that is 10. So if for a particular edge, if there is an associated value, then it is said to be a weighted graph. If there is no associated value with it, then it is an undirected graph. So here, based on the edge value, we have divided our graph in two types, that is weighted graph, unweighted graph. So in weighted graph, edge will have a value associated with it, and that value doesn't necessarily be positive. It can be a negative value, it can be a positive value, and it can be zero as well. Okay, here you can see that I am having positive value, negative value, positive value. So it can have either positive, negative, and zero values as well, right? So this is the type number 1 in terms of weight. So I will have weighted graph, or I will have unweighted graph. In unweighted graph, there is no value associated with the edge. So from this unidirectional, bidirectional, and weighted, unweighted graph, we can create different combinational graph. For example, I can create a graph which is unidirectional and weighted. For example, let us say that this is my graph. It is having some direction and it is having some value associated with it, like 10, 20, something. I can also have a graph that is directional graph, but it doesn't have any values associated with it. Here you can see that this is unweighted graph, this is weighted graph, and this is directed graph, and this is also a directed graph. Similarly, I can also have a undirected graph with weight. So here you can see that I am creating undirected graph with some corresponding weight. This is undirected graph with some weight associated with it. Similarly, I can create undirected graph with no values, with no edge values. Here this is undirected and unweighted graph. So these are different types of combinations that can be possible for different types of graphs based on direction and based on weights. I hope you have understood what is a edge, what is a vertex, and how we differentiate graph. What are the types of graph based on direction, based on edge. I hope you have understood. Now let us talk about how we represent a graph. How we represent a graph? If you recall the concepts of linked list, if you recall the concepts of binary trees, let us consider that this is my linked list. This is my linked list. Now if you recall the concepts, what I did to represent a particular graph without JCF, I'm implementing my graph from my linked list from scratch. Okay, so in order to implement that, I have created a node class. So I have created class node, and in the node class I have stored int data and node next. Like this I have represented a particular node of my linked list. Similarly, if you recall the concepts of binary trees, in binary trees what I have did, this is my tree, right? So in the class node I have created a node class, and in that I have created node left and node right. In this I will store my data of a particular node. Similarly, to represent a graph in our code, we have introduced 4 methods, and these are the 4 different methods that we generally use. And in our whole session we are gonna use the first method, because I will tell you it is efficient. I will tell you how, but we are gonna use the first method, that is adjacency list, and we have totally 4 different methods. By using these 4 different methods we can represent a particular graph. The first method is adjacency list, second method is adjacency matrix, third method is edge list, and the fourth method is implicit graph by 2D matrix. Okay, see, these are the 4 different methods by which we can represent a particular graph in my code. Now let us try to understand each one of them in detail. So let us talk about adjacency list. So adjacency list is nothing but list of list. What is the meaning of this? Is that in adjacency list, what I will do is that I will create a array, and at the indexes of array I will store the least elements in it. Least element which are neighbors to that particular vertex. Neighbors to that particular vertex. Like this I will store in the form of array list. I will store the elements. So let me tell you clearly what I mean. So I will create an array. Here this is my array, right? How many elements are there? 1 2 3 4. So I will create 0 1 2 3, right? I have created my array of 4 size. Okay, now at each and every index, generally what we do, we store a primitive data type. Now here what I will do is that in the place of primitive data type I will store different list. So here I will store list 1, list 2, list 3, list 4, and this list will store the information of a particular node. So for example, I am having 0 vertex, right? So for 0 vertex, what are the neighbors? Right, for 0 there is only one neighbor. Neighbor is nothing but a branch connected with another node. Here you can see that there is only one edge connecting 0 and 1. So in the list I will add 1 as my neighbor. So this will become my list 1. Similarly, for my one element, what are the neighbors I am having? I am having 0, I am having 2, I am having 3. So this will become my list 2. Similarly, for the second node, what are the neighbors? 1 and 3. So I will store 1 and 3, and this is my list 3. And for third vertex, the node elements, the neighbors are 1 and 2. So here I will store 1 and 2, and this will become my list 4. So here this indexes represents different vertices, and at that particular vertex I will store in the index I will store a different list. So list 1 will store 1, list 2 will store 0 2 3, list 3 will store 1 3, and list 4 will store 1 2. Right, this is how I will represent my adjacency list. That is, adjacency list is nothing but list of list. That is, for a given array, in the indexes of list I am storing different lists. Okay, I hope you have understood the concept of adjacency list and how we can implement it in code. How we can implement, I hope you have understood how what is the approach, what is the overall idea of adjacency list. So we will create a hash map or an array, and in that at each and every index I will store different list of that particular vertex, and in the list I will store its neighbors, its vertex neighbors. Okay, I hope you are getting it. Now to implement this in code, we can use the concepts of, I will create an array like this. I will create an array of v size. Here the number of vertices are 4, right? So I will create a array of size 4. That is, I will create an array of 4, and in this I will store different list. That is, array of array list. I will store like this by writing this in the place of int. I will store a different list. So the first method can be, I can use arrays of array list, and the second method can be, I will create a hash map, and in the key side I will store the index or vertex value, and for that particular vertex whatever the corresponding list I am having. You can see that for 0 I am having 1, for 1 I am having this list, so I will store the corresponding list value. And by using these two methods we can implement our adjacency list concept, but we are gonna use this first method. And one more thing is that you need to remember this, that is, for adjacency list there are some advantage, and we use this method around 75% of the time. All programmers use this. Whoever doing DSA with Java, when it comes to graphs, they use this method and they will implement graph using adjacency list most of the times, because we have some inherent advantages with adjacency list. And the advantages with this is, first point is, it is optimized. The whole approach of creating a graph using the concept of using the method of adjacency list is, it is optimized, and the time complexity will become big of k. And what is k? K is nothing but the size of your list. Here the size is 1, here the size is 3, here the size is 2. So it is totally dependent on the size of the list, and it is not dependent on how many nodes you are having. Because of this, it is very optimized in nature. And the second point is that no extra space. It won't take any extra space. We are basically creating an array, that's all. So it won't take any extra space in the memory. And the third point you need to remember is that it is easy to perform some algorithms which we study further to find neighbors. There might be some question that in question they might ask you, for this particular vertex tell me the nodes, tell me the neighbors. So what I can do, I already have a vertex and its corresponding neighbor, so I will basically print this list to my user, that's all. So for neighbor problems, whenever a user asks you for this particular vertex, give me the neighbors, I am already storing the vertex and its corresponding neighbors, so I will return its neighbors, that's all. So here basically I am performing a single operation. Whenever we get the concept of to give me neighbors, to give me this, it will become very easy to return the neighbors, to calculate the neighbors. Because of this, we use this method frequently or most of the times. Now let us talk about the second method. The second method is adjacency matrix. In adjacency matrix, we will create a two-dimensional array, and I will store whenever there is a connection. If there is a connection, I will check for, in two-dimensional matrix I will have column and row value, right? Let's say my row value is I and column value is j. So this represents two different vertices. This I and j represents two different vertices. So between these two different vertices, if there is a connection, if there is a network, then I will check what is its weight. If it is having weight, if it is having a connection and having weight, then I will store at that particular position its weight. And if it doesn't have any connection, the connection is not there, there is no network connecting these two nodes, then I will store 0 there. So I will create a two-dimensional array like this. Let me create it here. So my diagram is kind of worst here. I hope you understand. Okay. So Okay, now what I will do is that I will check the connections. Here you can see that is there any edge which is connecting 0 to 0? No, there is no edge which is connecting the node 0 with the node 0 again. So if there is no network, if there is no edge, you can see that there is no network like this. If there is no network or edge, then store 0 at that position. So here I will store 0. After that I will move to next column. Now I will see if there is a edge which is connecting 0 node and 1 node. There is a edge. You can see that the edge value is 1. So whatever the weight I am having, if the user didn't give you weight but there is a connection, then store 1. If there is, I am having some weight, then I will store the weight value. And what I am telling is that if the user didn't give you the weight value in the question, then basically he is telling that store 1 default. Okay, so here I am storing the weight value is 1, so I will store 1 here. After that I will check, is there any connection between node 0 and node 2? You can see that there is no connection. If there is no connection, then store 0. After that, is there any direct connection from node 0 to node 3? No, there is no direct connection. Then I will store 0 here. After that, similarly, for 1 and 0, there is a connection and its value is 1, so I will store 1 here. After that, for 1 and 1, there is no connection, so I will store 0. After that, for 1 and 2, it is having connection. 1 and 3 having connection. Now for 2 and 0, there is no direct connection, so I will store 0. And for 2 and 1, there is a connection, so store 1. After that, for 2 and 2, there is no direct edge here, so I will store 0 here. After that, for 2 and 3, there is a connection, so store 1. Now for the last row, there is a connection between 3 and 0? No. For 3 and 1, there is a connection. For 3 and 2, there is a connection. For 3 and 0, there is no connection. Like this, I will represent my whole matrix using this, and by using this, again, it will become easy to find the neighbors. But the problem with this concept, with this adjacency matrix concept, is that it will take big of V cross V space. Here we are creating a two-dimensional array of V cross V. Here you can see that the size of this two-dimensional array is V. If my V is 4, then I am creating a two-dimensional array of 4 cross 4. So the space complexity will become V cross V, and here we are not creating any space. This is one of the major difference. And one more thing is that the time complexity for performing search operation, for performing any sort of operation in graph, if we go through this method, then the time complexity will become big of V. And here you can see that we are getting time complexity of big of k, and big of k can be anything, but you need to remember that big of k is very less than big of V, and that is why I am telling you that we will use adjacency list most of the times, because it is optimized when compared to all the methods. I hope you have understood the overall approach of this method. Right, so whenever there is a connection, I will store the edge value. If the edge value is not given, then I will innately store 1. Okay, now if there is no connection, then I will store 0 at that particular position, or I will store null. I hope you got the logic here, right? And the disadvantages is 1, space complexity and time complexity. Right, now let us talk about the third concept. So here we will create a edge list. In the method 1, we were creating a array list. For arrays, I am creating different list, and at each and every position I am storing different list. Similarly, for edge list, I will create a edge type array list. I will create an array list of edge al is equals to new array list. I will create an array list like this, like I used to do using my Java collection framework. I will create an array list. After creating an array list of edge type, I will store the corresponding edges. Here, this is my edge 1, this is my edge 2, this is my edge 3, this is my edge 4. So you need to remember that each, let me, where is the class? Each node class for linked list will have int data and node next. Each node class of binary tree will have node left, node right. Similarly, edge class will have source, destination and the weight associated with it. These are the three fixed things for a edge class. Okay, now for this thing you can see that there is no weight. So if there is no weight, then I will ignore the weight parameter. Here I will ignore the weight parameter because in the question, in the diagram, there is no weight associated with it. Okay, so here I will store each and individual edges at different indexes, and this edge will store source. For this, source is 0 and destination is 1. This is destination, and similarly this is source, this is destination. Like this, for each and every edge I will store source and its corresponding destination. Like this, I will create a edge list. And one more thing you need to remember is that we are gonna use this concept. We will use this concept whenever you see that user will give you a question where we have to sort the edges, right? So whenever we are sorting edges, we directly use the concept of edge list. We implement our question using edge list because it will become easy to compare nodes in edge list when compared to array adjacency list. Okay, and the best example I can think of is that there is a algorithm called as minimum spanning tree algorithm. In this, we will create our tree in such a way that all the vertices are connected with minimum weight, right? So we are creating this sort of sorting, you can call it as a sort of a type of sorting type where we apply the concepts of sorting in graph. So to implement this concept, to create a minimum spanning tree in my graph, we use the concept of edge list. And another example is, I think we use the concept of edge list in Prim's algorithm. There is an algorithm called as Prim's algorithm. In that we use the concept of edge list. I hope you have understood the three different methods. The first one is adjacency list, adjacency matrix, and the third one is edge list. Now let us talk about the last one. So in the last one, the name of the method is implicit graph. So in implicit graph, user will give me a 2D array, and by seeing the question, I will assume that this particular question is related to graph, and I will try to solve the given question using the concepts of graph. For example, the best example is, you can see that I am having a 2D matrix. This is a 2D matrix, right? So I will convert this 2D matrix question into graph type question, and by converting this, I can easily solve the question with optimized time complexity. Okay, now how we gonna tell that whether the given question is related to graph or not? So here you can see that there is some source point. User has given me some source point. Let's say this is x, and this x can move upward, right side, left side, and downwards. Now in the question, user has given me some destination. Destination is 0, 0, and this source is having at a position I, j. Now user is asking me how you can go from source to destination in minimum steps. In minimum steps, how you can go. So this question is an indirect implementation of graph. So if we know the algorithms of graph, then this is an easy peasy question. So this is the fourth step. In the question, user or in the interviewer don't give you the direct concepts of graph, but he wants you to apply the graph concepts in different questions. And how we can observe, how we can identify that this particular question is related to graph or not is by experience. When you solve n number of questions, you will understand that this question can be solved using the graph concept. And one more thing is that I will tell you a shortcut that whenever a user is giving you a source and a destination and is asking you to go from source to destination in minimum time or minimum cost, then it is an indirect indication that that particular question is related to graph. I hope you are getting it. Now let us talk about we have talked about 4 different implications, that is adjacency list, adjacency matrix, and the third one is edge list and implicit graph. Now let us talk about where we use graphs. I have told you that there are n number of applications we use graphs in real time, and one of the best example which we generally think of whenever we think of graphs is maps. In maps, when you put location, right, let's say you want to go from Hyderabad to Vizag, right? So when you put the location, it will give you the shortest path between two corresponding cities, between two corresponding vertices. And how it is doing? Because it is somehow implementing the concepts of graph internally, right? And this is the same concept that is implemented by Uber, by Ola, by what we have, Zomato, Swiggy, all this delivery apps, Uber cabs apps use the concepts of maps internally, and the maps are implemented using the concept of graph. So this is the one of the practical examples, and here we can, using the concept of graph, we can travel from one position to different position like this in a minimum time. And we will study some algorithms called as Dijkstra's algorithm. There are some algorithms called as Tarzan's algorithms, Kadan's algorithms, Khan's algorithm. So in this algorithm, we will study how we can calculate the minimum position, minimum cost between two corresponding nodes. Anyways, I don't want to bore you. And the second best example is social media, right? So we use Instagram, and some of you guys use Snapchat, LinkedIn, Facebook, Twitter, right? So internally, how it works is that, let's say I'm a node, and let's say my username is the Jabir Hussain. So the Jabir Hussain is considered as a node in itself, and this node is having different connections. Let's say I'm having 100 followers. So here I will have 100 different followers, follower 1, 2, 3, 4, something like this. This node will have different form of connections, and it will create a network in itself. And this internally, social media is also implemented using the concept of graph. And the third example is delivery network. What I mean by delivery network is that, let's say there is a branch, Amazon branch in our city. Now in that branch, delivery boy left morning, he left from position A, and he has to go to position B and C and D, like this. He has different parcels to deliver. Okay, now internally, using the concept of graph, we can calculate shortest cyclic route. It means that first from this source where he has to go to the next position, such that it will take minimum cost, it will take minimum petrol. So by using this concept of graph, we can tell that what is the shortest cyclic path, because in the end of the day, he will come back to the garage of the Amazon, right? So he will come back to the office, Amazon office, at the end of the day, right? So through which path he has to travel such that the whole cost should be minimum. Again, we use the concept of graph. And one more interesting concept that you might have not realized is that in physics and chemistry, in sciences, basically pure sciences, we use the concept of graph. For example, there is a concept called as, in thermodynamics, we have the concept called as entropy. So entropy is disorder, and this disorderness can be calculated by using the concept of graph. And reactions of molecules and the structures of molecules can be studied using the concept of graphs, right? And one more thing is that routing. In your house, in your college, in your workspace, you might have seen routers. That is basically internet, Wi-Fi systems. So internally, what is happening is that internet is basically network. Computers are connected in networks. We have given, for a supercomputer, we have given connections to small computers. So this network is basically using the theory of graph. So this also, the implementation of routing algorithms can be done using the concept and the theory of graphs. Now one of the most important concepts you need to remember is that machine learning. Specifically, if I talk about deep learning, where we use the concepts of neural network. In neural network, we use the concept of computational graphs. Again, we are using the concept of graph. So the main point of this whole application thing is that you need to understand that we implement graphs in various applications that we can't even imagine, and we will talk about how we create graph, why and different algorithms. But you should be very clear that you are dealing with one of the top data structures, and you should listen the overall concepts very clearly, right? This is the main goal of this whole application thing. Now let us talk about how we can create a particular graph in my program using the concept of adjacency list. So the concept, the overall pseudocode will be, first of all, the concept is that I will create an array of size v, and at each and every index I will store the least value. Here for 0 index 1, 2, 3. So here I will store different least. This is least 1, least 2, least 3, least 4. Like this I will store different least at different indexes. Now for this given least, let's say this is 0 index, right? At 0th index, what are the corresponding nodes 0 is having? It is having only 1. Now for 1, its neighbors are 0, 2, 3, and for 2, its neighbor are 1 and 3. For 3, their neighbors are 1 and 2. So this is my least 1, least 2, least 3, least 4. Like this I will create different lists, and in the different list I will store the corresponding neighbors of that particular vertex. Now what is the code of it? How we code this concept in our program? So what I will do is that, first of all, I will define my edge class. Right, so in edge class, what are the things I'm having? I'm having source, I'm having destination, and I'm having the corresponding network weight. Here you can see that the edge is having some weight, so I will define weight. In the main program, after defining my edge class, in the main program I will create a array list of edge type, and in the array list I will create an array of v size. Here basically I am creating an array of v size, in that I am storing different list of edge types. Right, I hope you are getting it. Now I will run a loop, I will initialize this array, and after that I will add each and every element in my adjacency list. In my graph I will create a new nodes into my graph. Now it will become very clear if we code the concept. Now let us code this concept, let us code this thing. Now in the main program, first of all I have imported all the packages. Now I have created my graph class, and in the main program I have shown you how the diagram will look like. This is what I'm trying to create. This is what I'm trying to create in my whole program. This graph I'm trying to create, basically the basic diagram which we have dry run. This diagram I'm trying to create in my program. Now along with this I have given the weights of different graphs. Okay, now in the program, first of all I will define my edge class. So I will write static class edge, and each edge will have source, destination, and the weight associated with it. Okay, so here int source, after that int destination, and int weight. Now after that I can create a constructor public edge, and let me give some parameter int source, int destination, int weight. Now this dot source is equals to source. After that this dot weight is equals to this dot destination is equals to d. After that this dot weight is equals to weight. Like this I'm gonna initialize all the, here I need to give yes. Okay, this is how I will define my static class edge. That is, each edge will have a source, destination, and a weight. Now after it, in the main program, what I will do is that first of all I will create a array list. I will create a array list of edge type, and here I am storing the values in the arrays of array list, right? So in the given array, first of all I am creating array, and at each and every index I am storing the least value. So here I will write graph GRA. Let me give the name of my array list as graph is equals to new array list of size, let me give v, and here the number of nodes are int v is equals to 5, right? So here let me define v, now a statement terminator here like this. So if you recall the concept of array, so first of all I will write int, after arr square brackets is equals to new int, right? So here I am creating a integer data type, that is why I am giving int. Now in the above example I am creating a least type, that is why I am giving least of edge, and here my name of the given given array is graph is equals to new array list. Like this I am creating my whole array of array list. Like this is how I will create my arrays of array list. Let me write it here such that it will become easy to understand to you guys. Now after creating my arrays of array list, what I will do is that I will initialize it. Initially all the values are null, so I will initialize it with some new value, with some 0 value. So I am initializing all the elements. So I will run a loop for int I is equals to 0 and I should be less than graph dot length and I plus plus. In this what I will do is that for a particular given graph index I will initialize it with new array list. So new array list, like this I'm gonna initialize each and every index of my given graph. Now after initializing I will add the elements into my given array list. Okay, so what I will do is that let us talk about 0 vertex. So if you observe the 0 vertex, 0 is connected with only 1 and the weight along with associated with it is 1. Okay, so what I will do is that here I will write graph dot add, here I will create new edge, and at the position of source I will give 0, and what is the destination? For 0 node its destination is 1, so I will give 1 and its associated weight value is also 1. Like this I will add my 0 vertex. Now 0 vertex is completed. Here it is showing some kind of error, can't resolve. Here it is showing some kind of error because this is a array, right? So at that particular 0th index I am adding a list, so I need to give index here. Right now after this the 0th index is completed, the 0th element is completed. Now for 1 is connected with 0, 1 is connected with 2 and 1 is connected with 3. So what I will do is that for one vertex I will add graph of 1 dot add new edge, and the source now is 1 and the destination is 0 and the weight associated with is 1. Now after it, similarly I will copy the same thing, and what I will do is that I will basically change the destination. The source will remain the same but the destination will be 2 now, and you can see that the weight associated is also 1. So here I will store 1. Now again the same thing, that is graph associated distance is 1. Now 1 is associated with 3 and the weight with 1 and 3 node is also 3. So I will store 3 here. This is how I will add elements for the first vertex. Now let us talk about how I can add for the second vertex. So for the second vertex I will add graph of 2 dot add new edge, and here the source will become 2 and you can see that 2 is connected with 3 and 2 is connected with 1. So first of all I will store 2 and 1 connection and its corresponding weight is 1. Okay, now I will copy the same thing, here and I will run here, and 2 is connected with 3 and 3's weight, what is the weight associated is 1. Okay, now I will store 1 here and one more thing is that 2 is also connected with 4. So here I will write 2 and the destination is 4, and the weight associated with 4 and 2 and 4 is 2. Like this I will add my second vertex node. Now the third vertex node. Let us see the diagram. 3 is connected with 2 and 3 is connected with 1. So I will write graph of 3 dot add new edge, and the source is 3, destination it is connected with 1, and the weight associated with them is 3. Similarly I will copy the same thing here and I will paste it here. Now the source destination will get changed 2 and the weight associated with is 1. Right, these are the only two nodes which are connected with 3. Now let us talk about the last node, that is my fourth vertex. So for the fourth vertex I will give graph of 4 dot add new node, new edge. So here I will write edge. It is showing some kind of error. Okay, now edge, and the source is 4 and 4 is connected with only one node, that is 2. So here I will give 2 and the weight associated with them is also 2. So here I will give 2. Like this I will add elements, I will create my graph in my given program using adjacency list. I hope you have understood. Now if I want to iterate a particular neighbor for a particular vertex, then what I will do is that I will run for int I is equals to 0 and I should be less than. For example, I want to print all the elements associated with 2. So what I will do is that I will write graph of 2 dot size and I plus plus. Now in this what I will do is that I will write h e is equals to graph of 2 dot get the ith index, whatever the element present in the ith index of that particular list. I will take that and I will print system dot out dot print. I will print their corresponding destinations. Like this I will print the elements. Now if I save and run this, then you can see that for 2 the corresponding elements are 1, 3, 4, and if I run my code then my output should be 1, 3, 4. So let me save and run this. It is showing some kind of error. String args. Okay, here I need to give square brackets, string args. Okay, now let me save this and run. So you can see that I got, these are just warnings, so ignore them. Now you can see that I got the output as 1, 3, 4, and in the graphical representation the 2 node is connected with 1, it is connected with 3, and it is connected with 4, and I got the same output. This is how we will iterate the neighbors, and this is basically how we create the elements into my graph using the concept of arrays of linked list. I hope you have understood. Now I will stop here. I think the lecture is around 1 hour 60 minutes. So I will stop the lecture here, and in the next session, in the graph part 2, we will talk about how we can iterate in graph, how we can perform DFS, BFS operation, and we will talk about some other algorithms related to the concept of graph. I hope you have understood the overall concept, why graph is important, where we use graph, and how we create graph. So with that being said, I will see you in the next one.